In the not-so-distant past, applications were usually constructed as a monolith. This is where the application is designed as a single, all-encompassing executable. In a monolithic application, there are few to no internal interfaces. Internal components communicate with each other via standard function calls. This architecture usually leads to a tightly coupled system with all of the downsides that go with that. Thanks to tight coupling, the larger a monolith gets, the harder it is to make changes. Altering one part of a monolith can have surprising and unpleasant side effects on the other parts, kind of like the proverbial butterfly effect. The fragility of monolithic applications isn't their only problem. They are often difficult to deploy and scale efficiently. Deploying a monolithic app is usually an all-or-nothing operation. When you make changes to a subsystem, you're forced to redeploy the entire app. This is time-consuming and inefficient. Scaling a monolithic application is also difficult, and for similar reasons. One alternative is to scale vertically. This involves moving the application to a beefier machine with more CPU, memory, and bandwidth. But that gets expensive, and there's a limit to how high you can scale up. The alternative is to scale horizontally, like so. This involves running multiple instances of the application and having them share the load. But this only works if the application has been designed to coordinate with other copies of itself. Even if it has, horizontally scaling a monolith is an inefficient way of doing business. Usually, only one part of the monolith reaches its capacity limits at any one point in time. By deploying additional instances, you end up running duplicates of subsystems which you don't really need yet. That's an inefficient use of computer resources and therefore money. A microservice application is made up of loosely coupled services. In other words, the microservice architecture chops up a monolith into a bunch of separate processes. The pieces then coordinate together. The result is a distributed system. Microservices offer a number of distinct advantages over monoliths. Each service maintains strong, well-defined service boundaries. This means that all communications with a service occur through that service's API. Microservices are technology agnostic. Each service can be constructed using whatever programming language or technology you see fit. This is due to the fact that services communicate via web service calls, which are language agnostic, as versus native function calls, which are not. It's usually easier to scale up a microservice than to scale up a whole monolith. When one service nears peak capacity, all you have to do is spin up another instance of it and throw a load balancer in front of them. That's relatively efficient and cost-effective when compared to scaling a whole monolith. Each microservice is deployed on its own. This allows you to efficiently update and redeploy individual parts of the application. Teams can be organized around individual services. Then teams only need to coordinate at the API level, which can reduce the need to coordinate on implementation level details. And yet, microservices are not a panacea. For instance, it can be quite challenging to deploy a large number of microservices. Dependency conflicts between the various services are hard to track down and annoying to fix. Doubly so when these problems only show up on certain machines or in certain environments. Thankfully, Linux containers are the perfect solution to this kind of problem.